Hold on a second. I technically go do this. This is standard for me. Can you hear me okay?
Yeah.
In the back? All right, cool. So shout out if I veer away from the mic or whatever. All right, so there wasn't room in the title to write, like to add on, I have no idea what I'm doing. But I have no idea what I'm doing. So to be clear, I have no big ideas here. I'm not a thought leader. I have no idea what I'm doing, but I got started with Spec. I was really excited to dig in finally. I toyed with it before, but I finally had a sort of an opportunity to, I thought, use it in a more robust way. And I got stuck a bunch. And I, with Tim's help and a few other people's help in my company and various places, eventually, got stuck past that first snag and then got into another snag and then figured out how to get past that one. And I, thought, well, if I had those problems, maybe other people might have those problems too. So that's it. I'm just gonna sort of show some of the struggles I had in learning Spec and learning how to use it in this use case, which is, well, I'll get to the use case. It's other people's data. But before we get into the problem, I want to talk a little bit about Spec, just give a quick introduction for those who maybe never heard of it or have only a little bit heard of it. Which at least I think have a baseline sense of what the hell is it even, before we can talk about, the troubles I had with it. Okay, so Spec is a library, and its goal, as per Rich Hickey, is this. So Clojure has no standard, expressive, powerful, and integrated system for specification and testing, and Clojure.spec aims to provide it. So that's how Hickey describes it. I frequently describe it like this. So if somebody makes a mistake and asks me what I'm excited about, I corner them and I kind of go crazy, and I'll start with this. I think of it as an excellent tool for specifying and validating data structures and for testing and documenting functions. At least that's how I use it. Another way to think about this is sort of Clojure's answer to creating larger systems with a lot of code, but enabling them to stay maintainable and sustainable and to stay dynamic, to retain dynamicity. In other words, it's sort of, if you squint, an alternative to types. So one other thing I want to point out about Spec is that, as Hickey himself has said, it's not radically original or anything. Hickey wrote in the rationale, he wrote, almost nothing about Spec is novel. There's a lot of prior art. There's Prismatic's schema library. There's Herbert, contracts, RDF, schemas in general. If you have the immense luck and opportunity to work with XML schemas, congratulations. I envy you.
It's not so bad.
Well, hopefully it wasn't so bad. Hopefully, what it was. Anybody remember the XSD Relax War? Anybody?
Yes.
Oh, excellent. All right. I said hopefully that's enough background. Just kind of what the hell is it, right? I just wanted to establish what the hell is it, and hopefully that might help. And if the examples we look at, we put up some code, and the examples we look at are just completely, gibberish, just shout out and we'll fix it. We'll treat that as a bug and we'll do a just-in-time bug fixing. Okay. So here is an introduction to sort of the problem I was trying to solve. This is a snippet. Can everyone read this okay? In the back? Okay, cool. So this is a snippet of a data structure defined by a tool that I was using that I wanted to integrate with. I wanted to generate this data, I wanted to process it, transform it, stuff like that. I didn't define this data structure. The tool author defined it. So this is the other person's data, other people's data. And it's sort of typical JSON data structure. It's a bunch of nested maps or objects with properties, that kind of thing. Pretty straightforward. Any questions about this? Any thoughts? Okay, so here's just an alternate view of how to look at the same data. For all its flaws, YAML, I find YAML easier for humans to read. It's much harder for machines to read. But for humans, it's a little bit easier, at least for talks. So my goal was to specify this data structure, and this is just a snippet of it, but the whole thing with Spec. So I could do validation, generation, generative testing, stuff like that. This is where I personally hit the biggest challenge when I was starting out, these type properties. So to me, as a neophyte, it was perplexing how to figure out how to specify these different data structures, these different maps. In elements, that's a kind of an array of maps of a particular type, kind, and then in styles, it's an array of maps of a different kind. And for me, they both have this property called type. This is extremely common in JSON APIs and REST APIs. You see this all the time in organizations that are doing a lot of JavaScript and a lot of JSON. But I was at first sort of like, how do I do this? It was not obvious. So I want to dig in a little bit into why this was not obvious, because in some schema languages, it's completely it'd be bizarre to even have a problem with this. For example, in JSON schema, you just say this map looks like this. It has this key, it has this value, and the value has to look like that. And this map looks like that. It has that key, and it has that value. You describe them separately, and you're fine. But Spec is opinionated. And one of these opinions it has, these strongly held opinions, is that map keys should be namespaced. And that they need to be specified independently of the maps in which they're used. So instead of saying, I've got this map over here, and it has this property, happens to be named type, but it's got this shape, the value has this shape, and over here it's another map, happens to have a property named type, and just, they're not really conflicting with each other. In Spec, you say, I've got this key called type, and here's what it looks like. And then you define the maps separately in which you use that key and its value. So one of the problem statements that Hickey wrote in the rationale for Spec is that map specs should be of key sets only. Now, I don't fully know what this means. I don't have a comp sci background, but it seems short, at least, if it fit on the slide, so. And then there's this, not as short. Most systems for specifying structures conflate the specification of the key set, e.g. of keys in a map, fields in an object, with the specification of the values designated by those keys. Okay, let's see if we can move on. And so one of the stated objectives of Spec is to decomplect, sort of decouple maps, keys, and values. Formulated a different way in the same document, to keep map specs separate from attribute specs. So why? If this is if you're zoning out with this stuff and it's just gibberish, it was to me too. So maybe you all can help me understand it. I have a beginning of an understanding of it. Last thing here before we get onto some code. One of the guidelines in the Spec overview said that sets, maps, I don't know why maps are called sets. Someone enlighten me later. They're about membership and that's it. And that this is vital for composition and dynamicity. So I don't know what this means, but I do know that I like composition and dynamicity. So, Hickey seems fairly smart, so I'll give him the benefit of the doubt. I'll say, okay, probably knows what he's talking about, and I'll give it a try. If I don't get it, if I struggle, maybe there's an enlightenment at the end of my struggles. And that was, if we're going into this very hopeful, and I thought I'll just see if maybe working with it, helps illuminate what all this stuff meant. So let's see if maybe that'll be the same for all of us. So here's an example of defining something, ultimately a map, with Spec. When you look at most tutorials for Spec, tutorials, guides, that kind of thing, they show examples like this. So first we define a Clojure namespace. We create a Clojure namespace, in this case HUD.catalog. We define a spec named chords. So that's the name of it. That's a specification. And any value that conforms with that spec just has to be a string. It just has to, that predicate has to kind of return true on that value. That's it. And the description is also a string. So we've just registered a couple of specs with 2 different names. Here's another spec called building, and this is a map. We're composing together those other values, and we're saying the keys in this map should be coords and description. Now notice we didn't describe the values of those keys because we described them already. And this is how you do, or at least how you're apparently supposed to do maps with Spec. There's also map of, and there's other ways, but this is sort of one of the primary recommended ways to do it. Especially when you're talking about sort of like entity maps, or what's the other phrase people use, like, bags of data, that kind of thing, as opposed to a more ordered, I don't know how to describe the other thing, like a map of where it's always the same thing, the same kind of thing, and the same kind of thing, whatever that's called. Not just a big bag of stuff. A more regular map. Anyway, so this make any sense? So this is how you define maps in Spec. So raise your hand if there's a question. It's okay. Okay. Okay, let's talk about double colons for a minute, because unless you've worked with Spec or read about Spec, you may not have seen a lot of double colons in Clojure code. It's just syntactic sugar. It basically expands, the double colons expand out to a namespace, in this case, the current namespace. So if this is equivalent right here. So double colon coords is equivalent to, and in fact expands to, and it's in every way equivalent to, once you get past the reader, HUD.catalog/coords. So it's just a syntactic sugar, it's a shortcut, just shorthand in the reader shortcut, right? So it's super convenient, right? You don't have to write out the whole thing. And it's easier to read, and it's easier to type, except it's not always super convenient. So in this case, this is not going to work, because, let's say I want to define part of one of the keys of a map that describes an element, the key called type. Okay, those are the values, the possible values. This data structure defines a diagram, a software architecture diagram. So, and let's say I want to define another map, another entity called a style. It has a type, and those are the possible values. Well, this isn't going to work because they're going to clobber each other. The second one is going to overwrite the prior one in the Spec registry. Don't worry about, if you're not from registry, don't worry about it. Just the place where specs go. There's a registry. Sorry. I just exploded the minds. Sorry. All right. So, this isn't going to work. So maybe this is obvious, but this is sort of the trouble I had with at first. So let's show my first attempt to deal with this. Any questions about the problem I was trying to solve? Anything unclear? Okay. So my first attempt to approach this looked like this. That's a lot of code. Don't have to read every line. Just I'll describe it. In a nutshell, it's multiple namespaces in one file. I wanted to have all my specs in one file. I really like that cohesion. I want that to read like I'm building something. I'm building up to something. I define the pieces and then I put them together. So I thought, well, my problem is you type a double colon, it expands out to a namespace, the current namespace. Well, guess what? NS sets the current namespace. So, I'll just make a namespace, and I'll sort of group my specs by these various namespaces. This is what namespaces are for, really, right? Is to separate things that have the same name but different semantics. So I have this thing called type that has the same name in two different contexts. Context of an element, the context of a style, or whatever, a style, a diagram. They have different semantics. So use namespaces and give them different contexts. So you can see here, oh yeah, this is my notes here. This is what namespaces are for. So I defined, and it worked. It's all in one file, and it worked. It got the job done. My specs, you were able to describe the data structures, it validated them, and so I'm all happy. Except I wasn't happy. I think I was talking about this with Tim at one of these meetups a few months ago, and he reminded me that it's just, it's pretty non-idiomatic. I think it was, does it sound right? Yeah, to have multiple NS forms in a single file feels pretty weird. For a person who's used to Clojure, if someone's not used to Clojure, there's nothing to feel weird about, right?
I didn't
But
even know you can do that.
right, I didn't even know you could do that, right? It feels pretty weird. If you're used to Clojure, you open a CLJ file and there's multiple NS forms, and it's like, this is just bizarre. Also, I've sort of elided, you can see the ellipsis down there. I've sort of elided all the things I'm requiring, but each successive namespace would create a separate alias to the prior ones. So I could do composition and refer in one namespace to the other ones, because otherwise, because you're switching namespaces, all the aliases go away, right? Who knew that? I mean, so yeah, this is not great. I mean, it worked, but it's not really maintainable. It's not sufficiently maintainable for my standards in terms of the project I was working on. Okay, so here's attempt number 2 of continuing figure out what my approach is going to be. So here, I've only got one Clojure namespace in this file. And what I'm doing is I'm not using double colons anymore. This is probably too small. Maybe that's a little more readable. Let's focus in on that. Can you read this in the back? It's kind of small, sorry. But I mean, move forward if there's like one guy, this circle here. This is all right, I'm sure he's very nice. So hopefully you can read this. So basically I just dropped the double colons. I'm like, okay, the double colons are getting in my way. I want to define specs in various namespaces. And the double colons are just syntactic sugar. And I just not use them. Turns out, you can use the reader to expand the namespace in a keyword to a Clojure namespace. If it has an alias to a Clojure namespace, it'll do it. But a namespace in a key doesn't have to be a Clojure namespace. You don't have to actually have a Clojure namespace that exists in memory that corresponds to this namespace you're using in a keyword. I'm sorry, I know that was gibberish. But that's what I realized. And I just thought, okay, I'll just write out the namespaces, right? And so it's okay, here's an element, / my namespace is, I'll forget about the prefix, but I have an element namespace. I don't know why I've highlighted name, but whatever. I should have highlighted type. All right, you get the idea. So great, I've got separate namespaces, and it works. It works quite well. So this felt like progress. Hold on. So then I want to show, that's why I'm highlighting name here. One thing I want to talk about, one quirk of this approach, which ended up bothering me, was that if you'll see here, I'm actually sort of referencing a prior spec in my specs. So I'm sort of making a copy of a spec. So I have a spec called, my root namespace, let's call it FC4C. I have a spec called name. It's just a string in this case. I mean, it's not how it ended out, but that's how it was. It started out. Whatever, it doesn't really matter what it was, right? I got a spec called name. Then I made copies of that spec. And I don't know how it actually works under the hood, if it's like a reference or a copy, but it's equivalent in the end. So I made let's call it a copy, in each of my other namespaces. So I need an element name. I'll have a spec in the element namespace called name. Hopefully you can see that. And it's just a copy of the root namespace name. I need a name for styles. Same thing. So it's very repetitive and redundant. I didn't like this. And it felt like I wasn't using composition properly. I should define name once and then use it, right, and compose it with other things. So let me explain why I was doing this. So this is these data structures are stored on disk in YAML files. I parse them. That's the first step. I parse them, and this is what I get. Right. So before I even validate them, I'm parsing them from YAML, and I get a map. Just very straightforward. Just keyword keys, and arrays of maps with keyword keys, and very simple value scale. Mostly scalar values. Pretty simple. So here's what I heard my problem was. I thought that in order to validate this data structure against my spec, which use namespaces, I'll give you the punchline. I'll give you a spoiler alert. I was wrong. I thought, as a newbie, that I was going to need to add a namespace to every key in this map in order for the map to be valid according to the spec. because the spec keys use all these namespaces, and I was like obsessing with namespaces, and everything has to have namespaces, including my data. And I was wrong, but if you're constructing a map in your Clojure code, I think Spec does want you to use namespace keys and keywords. But I forgot that it also has a facility. I'm kind of screwing up the order here. All right, so I imagined that I would need to get it into a shape like this so I could validate it. I need to essentially, I thought I would need to do some sort of like a post-processing step before I could validate it, a processing step in between parsing and the validation, where I'd have to assign a namespace to each of those keys so that it could then validate it. And when I imagined writing that code that would know which namespace to assign to each key in each place, it felt like a disaster. Like it felt like I am not good enough to write that code, and it's going to be a mistake. I guess I've learned something over the years, right? I had this instinct, this gut, like, oh, this is spidey sense was tingling. Bad idea. And so that's why I copied those specs. So instead, I can do this. I can just say, okay, each of my things of a given kind is going to use every key in there is going to use the same namespace. I thought then it'll be easy. It's all uniform. It's easy to use like some recursive transformations function and just every key just to append a single namespace. Much more straightforward. So I thought I'd do this, and then it would validate. I'd have namespace keys, and I'd be able to use my spec to validate. And then I had this moment. Because it turns out that was silly, because Spec includes a way to, because Spec, the creators of Spec realized that you'd have to deal with other people's data and legacy data and stuff like that. And there's a feature for this. There's this way to specify a map that is going to contain unqualified keys. So instead of doing this, when you say this, and you say, here's my keys, and here's my map called style, and it's got some required keys and some optional keys. So when you do it this way, what you're saying is, yeah, those keys have to exist in my map, and they have to be like this. They have to have these namespaces. So they have to be there, and they have to be there like this. But there's also this. Just add those 3 little characters, and now you're saying, yeah, those keys have to be there, and you should validate them using these specs. But when they're actually in the maps, they don't have to have the prefixes in order to be valid, which was very convenient. And I was simultaneously relieved and very, embarrassed when I realized this. But it's kind of the story of my life. So what are you gonna do? Okay, so finally, my kind of where I was feeling really good at this point, where it came together, was this last step here. Let's see, this is just too small, but maybe this helps a little bit. You can see here I'm doing composition. I've got an element, I've got a spec called an element, and it's composing other specs. Like I've got specs from different namespaces that I'm composing together, and I'm using rec_un, saying that the data I'm validating or whatever I'm doing with it, generating, validating, it doesn't have to have, in fact, it's not going to have, qualified keys, and it works. I can compose my specs together, I can do validation, I can generate data, I can do generative testing, and there's no post-processing at all. I didn't have to do any, let alone, terrible post-processing, right? This is one of those cases where the best code you write is the code you don't write, sometimes. Or something like that. So I was pretty happy with this. The end result here, I've got a spec that thoroughly describes a diagram, one of these diagram data structures, using what feels to me like fairly straightforward composition. I've got a diagram, and it's composed of a type, a scope, and all these things are in the same namespace, and those things themselves are composed of things that are all in the same namespace, and it felt right at that point. Okay, I want to give a quick demo, but questions first, before, there was a lot of stuff. This is how my demos go, so be prepared. Yeah, please.
So I understand your point about cohesion, keeping everything in the same file. Did you have an attempt where you had things in different files, each their own namespace? Would that have to be worth entertaining versus the locality of one file?
Okay, so the question is, even though the appeal of having everything in one file is clear and cohesion is nice, did I try out having things in multiple files, having each namespace be in its own file? Maybe for a minute, pretty early on, but I was not happy with it. It was too many files, it was too fragmented, and it just had that spidey sense feeling of going in the wrong direction. So for me, it just didn't feel right. Any other questions, thoughts? What wasn't clear so far? I mean, we'll do a demo, we'll run some code. I have one more tweak I made that I want to show you, but before we get into the demo, please, anything? Okay? Okay, well, interrupt me anytime. All right, that's something. Cool. All right, good, let's do this. So, quick demo. Start up my REPL in my project with the stuff loaded up. I can make this as big as we need, or at least, hopefully. Can everyone read that in the back? Yeah, you okay? All right. So first, I'm requiring my namespace that has my specs in it, and it's just called Spec. I've got a file called spec.clj that has all my specs because that's a technique. That's what I did. And then I've got Spec itself, and then Clojure Spec Gen so I can generate some data because that's what I'm going to demo. It's super exciting. So we'll require all that stuff. Okay. Now here we will get the generator for this spec. So I've got a namespace. Here I'm not using double colons because I didn't create an alias for this namespace structurizer. So that's the name of this tool that I'm integrating with, by the way. I mean, I can talk later about, I'm trying to make a tool for making software architecture diagrams. I'm trying to enhance it, make it better, sort of add some features to it, sort of. Anyway. So that's the spec, structurizer / diagram. So get the generator for it, pass it to generate, which will generate one value, and then let's pretty print it. There we go. That's our generated value. That's a diagram. It's a valid diagram, and we can check it out. Is it valid? Can everyone see that? I'm saying, is it valid? So those who aren't familiar, in the REPL, *1 refers to the prior value that was returned by the prior command? What is a thing? What expression? Okay, thank you. Well, I mean, I expected this. Oh, thank you. pprint returns nil. Thank you very much. Beautiful. Hey! That was amazing. Okay. Anything else anyone wants to see in the demo? Like that's all I thought we'd just do that. But
Position is not parsed.
Position is not parsed. That is intentional. The tool structurizer wants position to be a string with like that.
That's not very nice.
That's a thing. I'm specifying someone else's data structures, right? I can't change them. I can't have an opinion about them. It doesn't matter. And one of the reasons I thought this talk might be interesting to other people is because this happens all the time. You're working with some API, and you've got to create a data structure as they specified it, and it can be really annoying. But you can bring some rigor to your system by specifying those data structures, and then you can generative testing. And I don't know. I find that very exciting.
It's like even being a string, is it always going to be like an integer, comma, an integer? Because like if that's the case, then you're going to specify that as well, at least for like a regular expression.
Yeah, so the comment was that this value here for a position, it's a string, integer, common integer. Even though it's maybe not the best way to represent this data, you could write a spec for that. And yeah, that's what I've done. I've written specs that generate this and specify it, and that is valid according to a regular expression. This is something, a quirk of spec. I thought, like, one of the cool things, one of the nice things about spec, I guess in affordance maybe, is that you can say, if you have a spec that, oh, that's not right, hold on. Let's say you have a value like this one. That's still too small. Come on. let's say you have a value where it's just like there's a set of enumerated values that are allowed. You can just use a set and just put those values right there. And that's just really nice. It's expressive. It's clear. It's concise. I thought it was really strange that you couldn't say, I think this is a very common need in the world of data validation. Any string that matches this regular expression is valid. There's no straightforward way to say that in a concise way with Spec, and I find that surprising. So what I ended up doing, let's see, is this too much of a tangent?
No.
No? Okay, all right. So there's this other library called test.chuck. Instead of test check, it's called test chuck, and it just basically is this collection of utilities and generators and stuff to kind of enhance and fill in some gaps in test.check, which is a generative testing library used by Spec. And so it has this cool generator called string from regex. So somewhere I'm using that. What was that?
No, because otherwise you have to do that by hand.
Yeah, right. Yeah, so I'm using this here. Again, maybe there is a simpler, more elegant way to do this with Spec that I just don't know. But this is what I ended up doing. I've got a spec called comma delimited simple strings. And so I'm saying, okay, this is a spec with a generator. I'm going to explicitly provide a generator for this, which I've got to do. And here's the validity spec. Here's how we tell if it's valid or not. So we're composing two different predicates. First of all, it has to be a string. Okay. Second of all, it has to match this pattern up here using a regular expression. This is what I figured out. How do you validate a value using a regular expression with Spec? This is how I figured out how to do it. And I looked at tutorials and guides, and I didn't see a more concise or elegant way to do it. But then I wanted to use this in generative testing, so then I've got that string from regex generator, where I just got to give it my pattern, and it's going to generate values that are valid according to that regular expression. So that was pretty nice. Big fan of that library. Only issue with using it is that if you use it, I think then you end up having to include it and test.check in your deploy package, because unlike this is maybe too much of a tangent, too much of a deep dive, but if you're just using just Clojure.spec by itself and its generative testing capabilities, it has some magic, so you don't have to ship test.check with your production artifact. You only have to use it at testing time. But if you're using test.chuck, you might have to end up having to ship this stuff with. So in my deps, I've got this whole long Megillah here explaining that this is why I have this here, because of blah blah blah. I'm using a generator and some code, and it has to. So okay. Okay, so where were we? That's the demo. I've got one last thing. Oh my god. All right, I'm going to skip my notes, and then we're just going to mirror, because who raise your hand if you want to wait while I fiddle with the mirroring. I just want to share one refinement that I came up with that I liked. After I was happy with this, and I was like, oh yeah, this is good, it's working. I got it merged. My coworkers were like, yeah, thumbs up. I got this refinement. So this is what I ended up with, and this is what got merged. And this is that case where I got just not using double colons, and I'm just writing out the namespaces. And I've got composition, and I don't have multiple namespace forms, so I was pretty happy with it. Except for one thing. This is hard to read. I just found it ugly and hard to read and hard to parse visually, and it didn't feel good looking at it. Opening up the file, looking at it, it just nagged at me. So when I should have been doing something else, I took some time and I tried to try one last thing to see if I could figure out a way around this. And I did. I made this namespaces function, which creates a bunch of namespaces and assigns aliases to them. And then I use them. So now I am using double colons. Turns out you can use double colons with an alias and a slash, and the reader expands those out to whatever Clojure namespace exists. And I find this much easier to read. So this is what I ended up with. So I don't have multiple NS forms in my file, but I still get to use aliases and double colons, and it's more concise and easier to read. This is creating multiple Clojure namespaces, which is a side effect that technically shouldn't be necessary, but it turns out I don't care. Whatever. I maybe improperly creating Clojure namespaces just so I can have aliases, right? But I don't care. I guess I could have done some customization of the reader or something, but that's beyond my pay grade. What's up?
Couldn't you have done that just in the NS expression?
Couldn't I have done this in the NS expression? I don't think you can create multiple namespaces in the NS expression.
Well, you're just creating aliases.
No, you can't just create an alias. You can only create an alias in a Clojure namespace to an actual Clojure namespace. It has to exist. So I probably should have put this in a slide, but I can just show the code. I guess I should be ashamed I have a util namespace. But anyway, this is all it does. It creates a Clojure namespace. It has to actually create a Clojure namespace, and then creates the alias to that namespace. And this is the only way it works. The alias will fail or raise or something if the namespace doesn't exist. One quick postscript. At a certain point, I was scrolling through the spec guide and I noticed this section and I was like, oh, what is that? Maybe I should read that. And it sort of finally caught my eye, and so this multi-spec thing is a way of using multi-methods with specs to sort of inject some programmatic logic and figure out which spec to use for a value, which is super cool and probably would have solved my problem much more elegantly and cleanly and simply and fastly. And maybe I did try this a little bit recently to try to apply it to my space, and I couldn't figure it out quickly. But it doesn't mean that it's not the right solution. So this might be the right solution, and this whole talk might have been a waste of your time. But it's not, though, because that's sort of the lesson here, right? So when you're learning something, you stumble around, and or at least I do. All right, so that's all. Well, any thoughts, any questions, any suggestions? What did I get wrong? Please.
One thing, I love multi-specs, but I think they are probably best if you have like that one vector, like elements or styles, like you had different things that you knew about. So I'm not necessarily sure what comes in there. Or like you might have just needed some companies. Anyway, that's not it. My actual question is
Can you speak up a little?
Oh, sorry. My actual question is like, did you guys end up doing a lot of generative testing with these specs, and like how did you find that? Like I did a little, and I was curious about your experience.
So the question is, did I end up doing any notable amount of generative testing with these specs? What was that like? And the answer is yes. It's one of the things I'm super excited about with Spec is generative testing. And okay, wait, let's introduce what that means, because I mentioned it before and didn't explain what it means. So a couple years ago, I was at Strangeloop, which is a conference in St. Louis, and one of the creators, maybe the creator of QuickCheck, gave a talk. Does anybody know who that is, or who? Anyway, but I don't remember if he was the sole creator or one of the creators. But QuickCheck is sort of the library that created this space. It's a Haskell library. It was a really inspiring talk, and ever since then, I've been inspired to try generative testing. And I think even at that time, test.check, the Clojure library, which is sort of inspired directly by QuickCheck, so there's a Clojure library for doing generative testing. It already existed at the time, so that's when I sort of got super excited about it. And then when I saw it in Spec, I said, this is going to make it more accessible for me to use generative testing. So what is generative testing? It's also called property testing, and please correct me when I get this wrong. But let's just explain it by comparing it and contrasting it with more conventional unit testing, which sometimes people call example testing. When you think up an example, you think up, okay, what's some input that I can pass into my function to test it, right? Some reasonable input. So I can say, okay, if this input comes in, this output should come out. You can express your expectations and assertions and things like that, and you'll have some examples. You're thinking up some examples, and if you're really robust about it, you'll make like a table. You'll have a bunch of inputs and outputs, and you'll do 5 or 6 assertions or something. So with property testing, you describe the properties of your inputs and your outputs. You describe what they should be like, sort of in a more general way. You could say you specify them. And then the framework generates as many examples as you want from those properties or specifications. So it could be 5, it could be 50,000. It's automated. And so you're expanding the number of assertions and tests you're doing, but you're also expanding sort of how crazy some of these examples can get. So I recently had I guess a ticket that I was working on, a feature I was working on. It took a week longer than I thought, because when you're using generative testing, it finds the edge cases. You know, so I wrote this function and I was like, oh, this collection is always going to have something in it, you know, but I didn't write the spec that way. So the generator was generating empty collections and passing them in. Then it forces you to think, okay, well, wait, what should I disallow that? Should I say the collection can't be empty? Okay, fine, I'll say that. That's one of the rules, right? Or decide what should the behavior of the function be if it's an empty collection. And so by forcing you to think about these edge cases, it forces you to make your functions more robust. It's easier to like follow Postel's law. Postel's law be relaxed in what you accept and strict in what you return, if you want to, which I do most of the time. Okay, where was I? So yeah, I recently lost a week. In a sense, I lost a week, but I'm very happy about that because I learned a lot. You know, I up until then, my sense of working with generative testing, what it got you, was very intellectual, was very theoretical. But now I've got it in my gut. You know, I don't actually believe in software estimates, but if I was going to do an estimate, it would be a little more accurate, slightly less inaccurate now, right? Because I've got a better feel for it, and I'm super excited about the potential for generative testing, with or without Spec, honestly, but I do like using it with Spec to make our programs more robust and more rigorous, really, is one way to think about it. Not just robust in terms of like, you know, failure tolerant, which is the one benefit, but also rigorous. You know, I don't know how to explain that, but it just feels right. Can I show some of this stuff? Yeah, so I ended up writing a lot of custom generators. This is something interesting. This might be interesting to hear. I didn't know this was going to happen, but in order to test a bunch of features, I ended up having to write a whole lot of custom generators. And I've seen some people talk on the mailing list about how that's where you end up. If you're using generative testing heavily, you're going to end up writing your generators explicitly as opposed to letting Spec kind of make them for you. Also, in my case, I'm creating a sort of an object graph. And I have objects that reference other objects by ID, so it's sort of an indirect object. It's not a memory reference. And when you generate the big thing, the references weren't lining up. So it's like, you know, people may be familiar with this problem with relational databases. You need to test something, you need to create this thing over there, but it has to have this over there and that over there, and you got to create this whole, you know, graph essentially, related entities. I had to figure that out. That took me a while to figure that out. And I ended up solving it to some degree of satisfaction, but it's a fairly simplistic, almost hacky solution, but it's okay for now. And somebody is writing a library, which is interesting, which you describe your graph, and then it generates a valid graph using your specs and the specification of the graph. It's called Spec Monster, which is a lot of fun to say, actually. Spec Monster. So look for the library Spec Monster by Daniel Higginbotham. I think he's about to release a 2.0 version, which looks a lot better than 1.0, by the way. Anybody else? Questions, comments? What did I get wrong? Yeah.
I was wondering if you use Clojure types and if that plays nicely. So.
Yeah. So Andy, let me know. Keep an eye on time.
Yeah, you're good.
Okay. So the question was if I've ever used Clojure.typed, and if so, does it play nicely with Spec? And the answer is no, and I have no idea. Anybody else? Does anybody here? I mean, this is a discussion, it's not just me. So does anybody here use Clojure.typed, maybe explored using it with Spec, or has actually used it with Spec? Anybody? Nobody in the room. So, I mean, you should try it, and then give a talk about it. What's up?
Did you spec any of your functions out with the FDEF?
So the question is, did I spec animate functions out with the specs FDEF function, where you describe your functions, your inputs and your outputs? I think that's the only way to do generative testing with Spec. You have to do that. That's how you do get the generative tests. Yeah. Let me just show real quick. We're not going to dig into it.
I have a follow-up question too.
Sure. 1 sec. This is one of my files. This is a big one. It's got 445 lines. I'm ashamed. But I've got a bunch of functions, and many of these functions, maybe even all of them, do have an FDEF, a spec function definition. So this one here, this is a function called sysposition, and this is a spec for that function. So it describes the inputs and the outputs. It specifies what are valid inputs and what are valid outputs. So I'm using a lot of this, and some of them are just simple like this. One or two inputs, one simple output, scalar values mostly, or almost scalar. Some of them are insane. No, that one's not insane, but this is one of the less insane ones. So a FDEF, a function a spec function I don't know what the term is for this thing. An FDEF expression can include this this fn value, where you can provide a function that will be passed the inputs and the outputs of a given invocation, and you can then do whatever you want to assert and confirm that the inputs, given those inputs, the outputs are valid, which is super cool.
Did you use instrument at all?
So the question is, did I use instrument at all, which is a spec function. It's in the spec testing namespace, spec test namespace, which it's meant for use during development and testing, where you can sort of instrument a function or lots of functions such that every time they're invoked, the inputs and outputs will be validated. And I started using that recently. So I didn't use it earlier on in my journey, but I should have. And now that I started using it more recently, I think what happened was one of my coworkers said, "This all looks good, but you should probably add some more specs and tests." I had a namespace that I shipped, and some of the functions didn't have FDEFs. And I thought, okay, I'll just throw those in there. It'll be cool. It'll take a day. But it took a week. Yeah. And I was doing a lot of debugging and figuring out why the hell is this not working and that not working. What's it called again? That function.
Instrument.
Instrument turned out to be really, really helpful in doing that debugging.
So I just like for like runtime checks.
What was that?
Are you using for runtime checks like?
Am I using?
Production.
Yeah, that was my question. 'Cause I know the spec guide says don't, but actually I have, and for some things, and I'm just kind of wondering what you did, or maybe what other people do.
No, I haven't used it for runtime. Runtime validation.
Yeah.
I guess it's validation. No, I haven't. I sort of. I only recently started using it even for its like main intended purpose, right? So. I'm still enough of a newbie that I'm like following the guidance of the creators. I'll come back to you in a second. Go ahead.
Yeah, have you used Spec with like Swagger?
So I think the question was, have I used Spec with Swagger?
Yeah, like Swagger Docs and Swagger Clojure.
No, but it does sound cool. It's a good idea. This is my first significant usage of Spec, more than just dabbling. So this is what I've done with Spec, is specify other people's data and get really confused and this kind of stuff. Sir.
So I actually had two questions, but to this point, so your FTEFs here have landed in the same places. The functions you were saying before, the specs of your data types were in a separate file. I started working with it, and my data type specs kind of landed in the same place as the code, and it's all in the same namespace. It kind of felt okay, but I don't know what best practices there, what makes sense. Is there a disconnect here where these are here and the other part of your spec is philosophically in a different place?
Yeah, so the question is asking about the apparent, I guess maybe inconsistency of having the value specs in a separate file, but then the function specs are interspersed with the function implementations here in this one file, and that seems maybe inconsistent or maybe just surprising. And I guess the question is, what are my thoughts on it? You want to know what I think. So I have thought about that recently, because I looked at this file, and just even scanning through the file, it's like almost hard to read, hard to follow. And so the ergonomics of this are starting to bug me. And also the file is just too damn long. I start to get uncomfortable at 400 lines. Call me crazy. Okay, so here's my thoughts on this. As a neophyte, just for what it's worth, I think ideally you would have a single file with your value specs and your functions and your function specs, right? If you're able to be successful in keeping things small, and I wasn't here. I failed. Everything's just sprawling and bloated. So it just can't all fit on one file. I mean, I could. If you look at Clojure core, there's 5,000 line files. I just personally, maybe I don't have good enough tooling, but I just don't get comfortable. I'm not comfortable with 5,000 line files, or even 1,000 line files. My spec file is, 110. So I'm starting to think of maybe breaking this file up, just because. Again, maybe I don't have the right tools. Maybe I should join the Church of Emacs. I don't know, right? But the ergonomics of this are not feeling quite right to me at this point. That's all I got to say. I don't have a best practice to share with you, but I can share with you where I'm at.